Hello, and thanks for joining us today for our webinar on an automated approach to data protection and data privacy. First, to go over some logistics, we will be handling any questions during the webinar through the Zoom webinar interface. So you should be able to type out any questions that you have, and we will either try to answer them in the course of the webinar, or we'll answer them at the end during the Q&A session. You should be able to see a button for Ask Any Questions at the bottom of the Zoom application. Also, this webinar will be recorded and will be available online as soon as we have finished processing the recording, so that everyone who is registered or attended will receive a notification when that video is available. You will also be provided with a link that you can share with anyone that you think would find this webinar useful. So with that, let's go into the agenda for today. Today, we'll be covering some of the challenges with data protection and data privacy. Some specific common practices within the industry for addressing those data protection and data privacy challenges. We'll talk about how to automate the data protection, data privacy controls, and then we'll go into some use cases and demos where I will be showing how the NextLabs solutions address these challenges. Finally, at the end, we'll have some time for Q&A. So with that, my name is Tony Burning, and I am a Senior Product Manager here at NextLabs. So first, what are some of the challenges of data protection and data privacy? At a high level, the main challenge is the need to share information and data with the need to protect that information and data. Organizations, businesses need to share that data, both for collaboration purposes, whether that's for external partners, supply chains, or anyone who is outside of their core organization who needs that information in order to operate effectively. By sharing that information, that improves an organization's agility and efficiency, so you can have faster time to market and take advantage of competitive advantages that you may have that may be temporal in nature. However, it's important to protect that data, and so that must be weighed against the need to share. So there's competitiveness issues, competitive advantage that derive from either proprietary data or customer data or supply chain data. All of that may be trade secrets that need to be protected for competitive reasons. And then there are also governance and compliance reasons to protect data. So depending on exactly where an organization is operating and depending on what types of data they may have, there are different regulations that apply. Also, often many times of different overlapping regulations that apply to the data that an organization have. So then the question is, how do you protect this sensitive information and still share it with the extended enterprise and partners so that you can do your business? So the need for data protection, data privacy is especially apparent in enterprise systems. So organizations, especially large enterprises, store, use, share sensitive data related to different business processes that must be protected from unauthorized access. There's a wide range of different types of data information. This could be things like PII, personal information covered by regulations, as well as would just cause a significant impact if it happened to be leaked. There's trade secrets like customer data, vendor data, supply chain information that are all trade secrets and give an organization a competitive advantage. And then there's also confidential financial information such as profits and losses, sales orders, bank account information. All of this needs to be protected. And a lot of times all of this is stored in enterprise systems that are shared between different organizations within a company, as well as with potentially with outside vendors who need access to some of that information. And there's many different combinations of factors that lead to an exploding number of different challenges. So there may be many sets of regulations dependent on the type of data, the places that a business is operating in. There's maybe multiple subsidiaries and locations that for an organization. If it's globally distributed, then if those are located in different geographic regions, they may be affected by different regulations. There's different types of data and technology. Some may be governed by export restrictions, while others may just be secret proprietary information or trade secrets. But there's different types of data and technology that all need to be protected in different ways. For large organizations, there's many suppliers and customers. So in both directions, there's suppliers that may be, again, geographically located that need access to some of the data, but can't have access to other parts of the data. And customers as well, or distributors, may also be geographically located and be dealing with regulations of their own. So if you consider these like A, B, C, and D, it's exponential in terms of the number of combinations of multiple types of regulations and multiple subsidiaries and multiple types of data and multiple suppliers and customers. And so all of these combine together to mean there's a lot of different combinations that all need to be addressed. So, and then finally, especially within the last few years, employees, partners, suppliers are more geographically distributed, and a lot of people are working remotely. And so depending on where they're working, that also impacts what needs to be done to protect data. So some of the ways that organizations deal with this, these are just some of the most common practices. So you limit access to the information onto a need-to-know basis. So by default, people do not have access to sensitive data, and they have to be proactively given access in order to be able to access it. Encryption or anonymization is very important. So that ensures that even if someone is able to get access to a system, if they don't have the appropriate credentials, then they aren't able to access the sensitive data, at least not in a usable form. We believe that everything needs to be designed in a data-centric manner. So focusing on the data that needs to be protected, not necessarily the networks or the systems where they reside. And then we also think that attributes should be the source of determining who has access. So instead of defining roles, which can be difficult, especially when you have the exponential number of different combinations of factors, things need to be attribute driven so that there aren't any edge cases that aren't covered. So a lot of this is really part of like implementing the principles of zero trust architecture, which at a high level is never trust, always verify before providing access to any bit of data. So some of the elements to any solution, and I will go into greater detail in subsequent slides. First is that you have dynamic data level controls. So those are data-centric security focused on protecting the data, not the networks or the systems where that data resides. Basing all data access policies on attributes instead of roles. Automatically evaluating those policies so that there aren't manual steps where there's both a chance for human error as well as a manual process is not scalable. And then finally, implementing the principle of zero trust architecture of enforcing policies at the location and time of data access request. So that if there are changes in attributes, if there are both the data or the user, those are reflected in the real-time enforcement. So going into these a little bit more in more detail. So for dynamic data level controls, specifically want to draw a contrast to network system application level controls that are aimed at controlling access to a network, a system, or an application. We're not saying that you shouldn't be using those types of controls, that you shouldn't be using network-based security or application-level security, but you should be implementing data-level controls and having data-centric security to complement those network controls. It's best to have multiple layers of security in any system, just to make sure that you have multiple ways that unauthorized access would be stopped. So specifically, dynamic data level controls are defined using the attributes of a user data environment and are evaluated at the time of the data access request, so that if any of those attributes change, that's immediately reflected, and a user that may have previously been authorized is no longer authorized as soon as those attributes change. And the opposite is true as well. Someone who was previously not authorized will be able to access data if their attributes change, and they are then able to access the data, authorized to access the data. Next, we have an example here of a data-centric dynamic authorization policy. At a high level, there are subject attributes. So these are attributes of the user. This may be their role, their title, their citizenship, their location, their business unit, what certifications they have. All of these are subject attributes. We're combining those with environmental attributes. So the location that the data residing, the time that's being accessed, the location of the user, where they're accessing it from, what network they're accessing it from, what type of connection they have, what type of device, factoring all of those in to make sure that you don't have valid credentials that have been compromised and are being used halfway around the world from where that user is expected to be. There's resource attributes. So this is for the data that's being accessed itself, what data type, if there's any metadata around that, if there's any classification, security, or otherwise, or even like export regulations that may apply. And then also the content of the data itself. And then by combining all of those attributes, you can then decide what actions are allowed, whether the user is allowed to just view, edit, create, delete, just defining that in a very granular fashion to make sure that users are able to do what they need to do, but only able to do what they're authorized to do. So here, one example is like allowing a customer service rep access to the customer sales data, but only for the customers that are in their same region or business unit, and only during their working hours, and masking this data for all other users. So here's another way to think about like the attribute-based policy definition. Again, we have identity, or the user attributes, and combining that with the context or the environmental attributes, and then the resource attributes as well. Combining all of those together, that you limit access to just the intersection of those, or what is allowed. So instead of who can access what, when, where, and why. So what it is that they can access, when are they allowed to access it, where are they allowed to access it from, and what are they going to do with it? Why are they accessing it? So this is another way of looking at how you would define like an attribute-based policy. So once those policies are defined, then another component is the automatic evaluation of those policies. So security requirements, as we've seen in our previous slides, can get very complex very quickly, just with a number of attributes, a number of different permutations and factors that are in play. And so that really is, it's not scalable to try to address or to create specific policies for each of those different combinations, or to have any manual steps in the process of evaluating those policies. So by having automatic evaluation of these dynamic policies, organizations can ensure that the same policy is applied, that it's consistently applied, that it's up to date, regardless of what system it's being accessed on, when it's being accessed, what scenario, what combination. If there's automatic application of these policies, and all of these are attribute-based policies, then organizations can ensure that, again, nothing is slipping through the cracks. There are no edge cases that aren't covered. And then the final point, which I have done here, is that by automating all of this, you can also automate the monitoring and logging and reporting for the evaluation of all these policies, which can be important both for demonstrating compliance with regulations, as well as for identifying any potential threats or flaws or breaches that may need to be addressed. So, and then the final piece is that all of this is done in real time, is when how policies are evaluated and enforced. So here's a bit of a diagram of exactly how this can break down. So I'm actually starting from the bottom. You've got the policy administration point, and that's where policies are defined. This should be done centrally, even if you're applying it to multiple systems, so that you can have consistent policies. Then you have as you get into when the data access request is happening. So you have the policy information point, the policy retrieval point. So it's like how the policies are getting retrieved, where they're getting referenced at the time of the data access request. And then that decision is being made at the policy decision point. So that's where the policy is being evaluated. All the attributes are being evaluated. The real-time data is being pulled in, and then the policy is being evaluated and at the policy decision point. And then depending on the decision made at that decision point, the policies are actually enforced at the policy enforcement point. And that's where the user is either authorized to access the data, or they're given like read or edit or write access to that data. But that's being done at the policy enforcement point. The key thing is that all of this is being done in real time. You can define the policies in advance, with the attributes, but then the attributes themselves are evaluated in real time, or retrieved and evaluated in real time. And then the policy decision, the policy evaluation is happening in real time with those real time values for those attributes, and then is being enforced in real time as well, just to make sure that is always happening with the most up-to-date information and is accurate. So all of these are principles of evaluating, are implementing zero trust architecture. So at a high level, what zero trust architecture, in a nutshell, it's always verified, never trust. So that's where the zero trust architecture terminology comes from. And this is actually defined by NIST as for what some of the general principles should be. So instead of controlling access to a network or resource, and then once you've, or what is called like the castle and moat approach, you can no longer assume that if someone has gotten access to the network that they can do everything within the network. Instead, that should be paired with the attribute-based access policies, real-time evaluation, the data-centric security, where you are protecting the data itself that needs to be protected. Even if someone has gained access to a trusted network, you still re-verify that user's access when they try to access some sensitive data or controlled data. The data must be protected. It's not the perimeter. Again, can't emphasize this enough. I'm not saying that data-centric security is a complete replacement for network-centric security. We believe that the two should be implemented next to each other so that both are in place. But we do think that you cannot rely on just the network-centric approach. It must be paired with a data-centric approach. So going into a little bit more detail, so in the NIST 800-207, there are two goals of zero trust or zero trust architecture. So one is to prevent the unauthorized access, but then also making that access control as granular as possible, and those decisions for access as focused as possible on the data that needs to be protected. So there's three core areas where zero trust architecture is focusing, like enterprise identities and the devices that are being used, the resources, and then the verification systems that are powered by the dynamic authorization policy engine. So those are the three core areas. And then, one more, slide on, like, what are some of the core tenets of zero trust architecture? So everything, whether it's applications, data sources, documents, data, is all considered resources. All access to those resources is verified and secured, regardless of where those are located. The authentication and authorization is enforced before granting access every time that access is being requested. And the key is keeping everything in the most secure state as possible, making the controls granular and focused on the specific data elements that are needing to be protected. So once this is implemented, some of the benefits are that it really simplifies the process of controlling access to secure data, secure information. So it externalizes that, it applies it across multiple systems, but it allows you to really simplify, the process of defining the access controls and the policies, because they're attribute based instead of role based or covering all the different combinations. That allows the business to be more agile as well, because you can really define the data that needs to be protected and focus in on the attributes that are needed to allow access to that data. But it doesn't require completely rewriting everything every time an attribute changes or some data changes. This also reduces the costs of implementing security as well as demonstrating compliance. So as everything is automatically evaluated, enforced, and logged, that removes a lot of the manual processes that can be very expensive and not scalable. And then finally, all of this helps enforce better data protection and data privacy. It's much more effective than other approaches. So here at NextLabs, our solution, to going over at a high level, is as laid out. There's a lot on this slide, but just covering at a high level detail. There's the attribute sources where information about the user, this could be identity, authorization systems, or the data itself, or the networks. Like all of these are potential attribute sources. They feed into our policy management, monitoring, and audit. So where the policies are defined centrally, those policies are then evaluated on different systems where the data is being accessed. And then the policies are enforced, both with the attribute-based access control. This is accessing data, whether it's through SAP or SharePoint or any other place where data can be accessed, as well as through digital rights management. So this is encrypting data and only allowing it to be accessed and decrypted by the users that are authorized to do it, even if the file or the data is moved from the system where it was encrypted. So again, at a high level, the key elements of boiling it down is that we have the attribute sources that provide information on the data and the user and the environment. The NextLabs control center is the piece where the policy is defined, centrally defined, and where you're also managing the logs and like the auditing of those policy applications. The dynamic policy evaluations, where the policies are evaluated in real time at the time of data access. So that's the attributes are always up to date, and you're using the current values of the attributes. And then the policy, the runtime policy information, that's at the data level. So it's not restricting access to the applications or the systems or anything else. It's actually restricting access to the data in the most granular level possible. So for the NextLabs solution, this is, there's key functionalities that help us to address that approach or be successful in that approach. Just attribute-based access control. This is in contrast to role-based access control, but this means defining policies in terms of the attributes of the user's environments and the data itself. Centralizing the policy management so that you can apply policies across multiple systems consistently. The dynamic runtime policy enforcement, so evaluating the policies in real time at the time of data access, and then allowing access to users at that time. And then we have for the policies themselves, there's both field level masking, so obfuscating, masking the data on a field level, even within a record that a user is allowed access to. If they're not allowed access to specific fields, that can be masked and obfuscated when they access it. There's also record level filtering, so even removing certain records for users that are not able to view them. And then after all this has been implemented, there's the centralized auditing and reporting. So for both compliance purposes as well as just general audit purposes, everything is gathered centrally so it can be evaluated. So, and then all of this is paired with like the automated digital rights protection as well. So this is protecting data, even if it's removed from the original system where it is encrypted and protected. The NextLabs digital rights protection goes with it to make sure that no user is ever able to access that data unless they have current authorization. So now I'll move into some use case demos for data protection, data privacy. I'm going to be showing demos in different products that the NextLabs solutions work with. I'll show an example in SAP, show an example in Microsoft SharePoint, show an example in Microsoft's Power BI, and then finally, I will show an example using our SkyDRM product to protect file contents. So with that, I will now go into the demos. In this demo, we'll show how you can mask bank account details based on a user's department and region. Specifically, we will implement a masking policy so that the bank account key is visible only to users who are in the same region, and it's partially masked for everybody else. The bank account number will be visible only to members of the finance department who are in the same region, and will be fully masked for everybody else. So in this example, we will have 3 users: Citizen US, Citizen US2, and Citizen DE. We will be using the user attributes of region and department and the data attributes of region to determine what data should be masked. First, we are viewing the business partner record as the Citizen US user, who is both a citizen of the United States as well as a member of the finance department. As you can see, for them, US bank accounts are unmasked for both the bank key and the bank account number, while bank accounts for other countries, such as Germany or Hungary, are fully masked. Next, we'll see how this looks for the Citizen US2 user. This user is a citizen of the US, but is not a member of the finance department. So for them, the bank keys are unmasked, but the bank account numbers are still masked. Both the German and the Hungarian bank accounts are fully masked. Finally, we'll view this as the user Citizen DE, or the German citizen user. This user is a German citizen and a member of the finance department, so they will see German bank accounts, bank keys, and bank accounts unmasked, while both the US and the Hungarian bank accounts are still fully masked. In this demo, we will show how you can use Attribute-Based Access Control, or ABAC, to restrict access to files in Microsoft SharePoint. Specifically, we will define policies to restrict users from uploading files related to projects that are still in development. So we will be using the user attributes of role, project, and components, and the data attributes of project and components to determine which users are able to see which files, and which users are able to open different files. In this example, we're going to take a look at using the NextLabs SharePoint Enforcer to manage access to structured data within SharePoint. We have set up two libraries, one for visit documents and one for sensitive documents. We'll start with the visit documents. The library has been set up to have a policy that restricts users from uploading documents related to visits that are still in development. So only production visit files are allowed to be uploaded to the visit document library. To see that in action, we're going to take the same files that we've been using and upload them to this document library. So we can see immediately that 3 of the files failed to upload because the policy denied them, saying they're not authorized to be uploaded here. And those are the files related to development visits. If we refresh, we can see the 7 remaining files are what's left, and we're going to check those in so that everybody can see them. So now everyone sees the same list of documents in the document library. Here we are Bob, and he sees those same files. Chris sees the same 7 files as well. However, their access to the files is still limited. For example, Bob is not part of the Intrepid project, and so if Bob tries to open an Intrepid file, he's denied. But if Chris tries to open the Intrepid files, he is authorized to access them. So there we have access control using the SharePoint Enforcer, where users see all the files, but they're limited on what they can open. Next, we're going to look at the sensitive documents library. The sensitive documents library allows you to upload all of the files. There are no restrictions against the files related to development visits. Anne is going to attempt to upload all the files to this library. As you can see, she is able to upload all 10 files. The difference is that we've set up trimming on this library. And what we've done is configure the trimming to only show users the files related to visits that they're assigned to. So, if you're not assigned to a particular visit, you're not going to see the files associated with that visit. For example, if Bob goes to the sensitive items and refreshes the page, we see that he only sees the files associated with the visits he's assigned to. He doesn't see Intrepid, for example, but he does see all the files for the Jupyter project. Even the files related to Spoke, which he doesn't have access to. That's because the way we've configured the trimming is based on visit. But if he, even though he sees Spoke, if he clicks on it, he still gets denied access. And Chris, in the same way, if he goes and refreshes his page, he only sees files related to visits he's assigned to. For example, he doesn't see NextGen or Epsilon. He's able to view and open the project files, and he's authorized to access as well. So here we can see that NextLabs SharePoint Enforcer manages not only access to structured files within SharePoint, but is also managing things like the ability to upload files to a specific location as well. In this use case, I will demonstrate how you can use NextLabs to filter data in Power BI that is accessing that data from an SAP HANA database. We will be filtering the financial records based on the user's company codes and the company codes for the financial records. We will have two users, one, HDB Demo User 1, that has been granted access to financial records from both company codes 1010 and 1710. The other user, HDB Demo User 2, has only been granted access to records associated with company code 1010. These records are being filtered at the database level, so the results of these policies will be shown regardless of the front-end tool that is being used to access the database. In this case, however, we will be showing how Power BI is connecting to the SAP HANA database as its data source. First, we can take a look at the database. Here we can see there are two users in the SAP HANA database, HDB Demo User 1 and HDB Demo User 2. We have a report that is built on the HANA database calculation view called CV AC Doka CDS. It is a CDS view provided by SAP, so we have a report that has been built and published to Power BI. Now, we have logged into Power BI. We can see that there is a report in Power BI called Financial Postings by CC. When you run the report, it retrieves the data from the database and displays it in the report. When connecting to the database, it uses the credentials that are specified in the query parameter. These credentials are currently set to use the HDB Demo User 2 user credentials. Here we can see the data source settings. If we go into the credentials, we can see that this is currently set to the HDB Demo User 2 user. Since the HDB Demo User 2 user is only authorized to see records associated with the company code 1010, the records will be filtered to only show those in the report. Here, we can see that the data that was returned. As you can notice, all of the records are associated with company code 1010. Now, we can try to connect with the credentials for HDB Demo User 1, who is authorized to view records for both company code 1010 and 1710. We'll edit the query parameters to use this user to connect to the database. Now, when we refresh the report, we will see how we are now able to also see the records for company code 1710. This shows how we are filtering the records at the database level based on the attributes of the user and the data, and this filtering is being done in real time at the time of data access request. In this demo, I will show how it is possible to protect the contents of files with NextLabs SkyDRM product. Specifically, in this demonstration, I will show how a policy can be created that allows users from the engineering department to access a file during a specified time window. Then, we will update the policy to apply a watermark to that file, even for the engineering users. And next, we will also again update the policy and change the window of time for which users are allowed to access the file. We will be opening the file with the same user for each of these times and show how, even with the same user and for an existing file, the policies will always be evaluated in real time to allow proper access to the file for that user based on the policy. Here, we have logged in to SkyDRM as an administrator to edit a policy. This policy allows engineering users to view, edit, and print documents with a classification of confidential. If we click on the policy, we can view the details of how it is defined. Here we can see how the policy is defined to apply to resources that have been classified as confidential. We can also see that it is defined to apply to users who are in the engineering department. We can also see how they are authorized to view, print, and edit these resources. This policy has been defined to be valid for the month of October 2021. Now, we can see how a user, Bob Elliott, has created a Microsoft Word document called sample.x on his local system. He logs into SkyDRM and goes into the Acme folder within his workspace. Here, he can choose to update that same file that he has created into the SkyDRM workspace. He selects the file and uploads it. As part of the upload process, you can specify that this file is confidential. We can check the date on the system to see that it is currently within the authorized window. Now we will open the file. Here we can see that the file is fully viewable and editable and does not have a watermark. Now we will log in as the administrator to NextLabs Control Center. Here we will update the policy that governs access to the file. Within this policy, we can specify that a watermark should be added by enabling the OB overlay option within the obligation section. We can set the specifics of what the text of that watermark should be. Now we save and deploy the policy, and we will go back as the same user to view the same file within SkyDRM. Now, when we open the file, we can see that a watermark has been specified according to the pattern that was defined in the policy. Now, we will log back in as an administrator and update the policy, changing the policy to only be valid through an earlier date. Here we are setting the end date of the policy to be October 10th instead of the 31st. After saving and deploying the policy, we again log in as Bob Elliott and go to the workspace and attempt to open the file. This time, though, when we attempt to open the file, we see that we are not authorized to view the file because the policy end validity date has already passed. This demonstrates how the rights and privileges associated with a document can be updated by an administrator to apply to existing files, and those rights will be enforced at the time the file is accessed. This is true for things such as adding a watermark or for allowing access to the file. Okay, everyone. Now we'll open it up for any questions and answers for a Q&A session. So any questions that you have, you can use the Zoom webinar interface to ask any questions, and we'll go through them. Just as a reminder to everyone who may not have joined at the very beginning, this webinar is being recorded, and a recording will be sent out, or a link to the recording will be sent out to everyone who registered or attended the webinar. So look for that in your email, and then also feel free to share the link to anyone who you think would find the content useful. We'll go ahead and answer any questions that you have now. One question is just a clarification question on some of the content around using data-centric security, is whether there's any situations where you can actually eliminate the need for role-based security. I would say that, as I mentioned earlier in the webinar, We think that a combination of the two, of both of a role-based approach with a data-centric approach, um, or attribute-based approach would would be best. Again, the more layers, a lot of times the analogy that's used is a Swiss cheese analogy for security. So that even if uh, malicious actor gets by one layer, they're stopped by another layer of security. So we definitely think that there's still a lot of benefit to having roles defined and having roles-based security and even network-centric security to complement the data-centric approach. Um, and we think that the data-centric approach and attribute-based approach is more effective, but there's no reason to eliminate a network-centric approach or a role-based approach. I'm not seeing any other open questions right now. I'll just wait for just a second. Um, but if you do have any questions for afterwards, definitely feel free to contact NextLabs. Send us any questions. We'll be happy to answer them. Happy to actually set up meetings as well to go over your company's specific needs and the specifics of exactly how NextLab solutions can be used to address those needs. Um, but with no other open questions, we'll go ahead and close out the webinar. Again, thanks to everyone for attending, and please do feel free to forward the recording to anyone who would find it useful, and then let us know if you have any questions. Thanks again.